So this is chapter 2, day 22, collecting like terms. This is a topic that we've actually done a little bit with, but on this material, it's going to be a little more complicated. So we're going to do a yes and a no. Yes, you can add it. No, you cannot. But first, let's do the rule. The rule is that to add or subtract terms, any terms, to add or subtract terms, the letters or the variables must match exactly. To add or subtract terms, the letters must match exactly. Now, multiplying and dividing is totally different. You can multiply or divide anything under the sun. But for adding and subtracting, it's really picky. The letters have to perfectly match. All right, so down the middle of your paper, first draw a crossbar. And then down the middle of your paper, I want you to draw a line. We're going to make a big, giant T-chart. A yes column.
All the way down on paper.
And a no column.
All the way down.
Yeah. All right, so in the yes column, x plus 2x. Both of them have a single x, so yes, you can add them. Remember that an x has an invisible 1, so you just do 1 plus 2 is 3x. When you add, the letters do not change. You add an x to an x, you should get an x. All right, in the no column, x plus 2. You cannot add these together because one of them is an x term, the other is a number term, so you would be done. That would be added. All right, number 2. xy minus 2xy. Like terms can be more than one letter. These two match perfectly. They both have an X and a Y. So yes, you can add these together. Again, this is a invisible 1. 1 minus 2 is negative 1 XY, or just negative XY. So in this one, if you have an XY minus a 2Y, even though they both have a Y, they don't match perfectly. If they don't match perfectly, you can't add them and you're done. Number 3. X plus 3y minus 5x. What if your terms are not next to each other? Can you still add them? The answer is yes, because we have this property called commutative property. Remember that, of addition, which means you can change the order and put them together. So you can go x minus 5x, move it over, and then plus 3y, so that the x's are together. And now you can actually put them together. 1x minus 5x is negative 4x. And the plus 3y stays separate. Notice that when you add like terms, your answers need to be alphabetical. X's before y's.
Can you go up?
I'll go backwards later. All right. X plus 3z plus y. In this one, they are all different. So I can't add any of these together. So your task then is going to be just to reorder in alphabetical order. So you have to put them in order, but you can't really add them together because none of them match. So in the alphabet, it goes X, Y, Z. So in your answer, it will be X plus Y plus 3Z. And again, commutative property lets us put them in the right order. All right, last one. Number 4. H plus H minus H plus 5J plus 1. Well, this is already in the right order, H-I-J-K, right? And the number term always goes last. So remember, if there's no number, it's a 1. So that's a 1, that's a 1, that's a negative 1. So when you add the like terms, which are the H's, you go 1 plus 1 is 2H, and then 2H minus 1H, 2 minus 1 is 1H. So just go left to right. Now we have been practicing that quite a bit just without the letters. Bring down the plus 5J and the plus 1, and you are done, and it's in the right order. H squared plus H plus H cubed plus 1.
It's cute. Can you start it?
Cubed means to the power of 3. So these are all H's, but they don't match perfectly. There's 3 H's here, 2 H's there, 1 H there. They have to match perfectly to add or subtract them. So none of those can go together. But we do need to put them in the right order. So if you remember, when you order, it's alphabetical, but it's also descending powers of X. Descend means to go down, like you descend stairs. So descending powers, in this case of H, so you go high power descending to low power. So the H cubed goes first, then the plus H squared, then the H. So 3 H's, 2 H's, 1 H, and the little number is always last.